Welcome. So the first topic we asked you to read about today is lists in Python. And like a string, a list is a sequence of values. If you remember, strings are sequences of characters. A list is a sequence of arbitrary values, doesn't matter what type of value, and those values are known as the elements of the list. So for example, you can see here we have one example of a list which is 4 integers, and we separate the individual elements with commas, and we surround the list as a whole with square brackets. And then this next list here, the second list, is a list of 4 strings, again separated by commas, surrounded by brackets. And there's no requirement that the values all be of the same type. So you can see here we have a list that has a string as its first element, then an integer, then a string, and then here the fourth element in this list is itself a list. So we actually have a sublist here which contains 2 floats, and that's perfectly fine as well. And once you have a list, you can do pretty much everything you can do with a string. So the operations we spoke about last week, things like indexing to get a single element, slicing, those things all work here. So what I've done is I've taken the list containing the 4 strings that you see here, and I've assigned it to the variable majors. And I've also, just for the sake of clarity, put the index numbers up here at the top. So remember, when you're using non-negative index values, they start at 0. The leftmost element, the leftmost item is item 0. And so when I say majors brackets 2, I'm going to get the string English because that's the one at position 2, the third element of the list. And when I ask for the slice given by 1:3, I'm going to get a sublist containing everything from element 1, which is the string math, up to but not including element 3. Remember, when we do a slice, the end index, its value is not included as part of the slice. So that holds true here with lists as well. We can also do things like figure out the length of the list using the len function, just like we saw with strings. So notice here the length is 4 because there are 4 elements in the list. We can concatenate lists together. So here I'm taking the list represented by the variable majors and concatenating a list containing just the string physics, and that produces a new list with 5 elements, as you see here. We can also do skip slicing. So we talked about that last week. If you specify a third number, it tells you how much to skip between elements when you're forming your slice. So here, because I'm not putting any numbers for the first 2 values, for the start and the end, I'm going to begin with the entire list, but then I'm doing a skip slice where the stride is -2. So take a minute, given what we talked about last week, see if you can figure out what the result is here. And what I'm going to recommend you do is actually pause the video. We're going to be doing this at several points today. Pause the video, figure out the answer, and then start it back up to see if you're right. Okay, welcome back. So hopefully, if you were able to remember how this works, because we're doing a negative stride, we're going to go backwards through the list, starting at the end. And because it's -2, we're going to get every other value starting from the end. So what we end up with is this sublist. We start with the last element, which is the string psych, and then we skip 2 backwards and get the string math. And then if we skip 2 backwards again, we're outside the list, and so therefore we're done. So that's what we end up with when we do that skip slicing. Okay, so given what we've just reviewed and given what you read to prepare for lecture, go ahead and give this clicker question a try. Obviously you can't actually register a vote today, but pause the video, see if you can figure out the appropriate answer here, and then start it up to check your result. Okay, so this was kind of a trick question. It turns out the correct answer is E. None of the above were correct. So let's see why that is. So we start with this list that you see up here, and it has integers for the first two elements, and then it has a sublist containing 3 integers as its third element. We assign that list to the variable mylist using this assignment operator that we talked about, and then we're printing the result of these expressions. So the first expression is this one here. It's an indexing where we're just getting the element at position 1. And that expression is going to give us just that single integer 2, because it's the element at position 1. But then, when you look at the next expression, it's a slice, right? Because we're saying 1 colon 2. It's going to be a slice of length 1, because we're going to start at 1 and go up 2 but not including 2. But because it's a slice, we're not going to just get the element at position 2. Instead, we're going to get a sublist, and it's going to be surrounded with brackets. So that was the trick here, that you had to realize that when you do a slice of a list, you're always going to get a list. Those brackets are always going to be there. And therefore, the final output here is 2, followed by a space, followed by 2 in brackets. Okay. So the key difference here is if you're working with a string, both slicing and indexing produce a string. So for example, if we have the string terriers, we assign it to the variable s. If I do the slice from 1 to 2, and again, that's going to be a slice of length 1, that's going to give me the E, because that's the character at position 1. And if I just do indexing and say give me the character at position 1, I'm going to get the same thing. So for strings, both indexing and slicing are guaranteed to produce a string. But for a list, slicing always produces a list. We saw that on the previous slide. But indexing does not necessarily give us a list. It could, but more often it gives us just a single element on its own without any brackets at all, because the only time you're going to get brackets from indexing is if the element is itself a sublist. So take, for example, this list here. We have a string as the first element, then an int, then another string, and then we have this sublist containing 2 numbers. We're assigning that list using the assignment operator to the variable info. And so here, if I do a slice from 1 to 2, I'm going to get a sublist containing 1977. But if I do indexing and ask for the element at position 1, I'm not going to get a sublist. I'm just going to get the element itself, which in this case is just an int. So that's a really important difference between how these 2 key operations perform in the context of strings and lists. Now, in the case of info -1, there I do get a list, even though I'm doing indexing, because it turns out that the last element is a sublist. And so because that element happens to be a list, I do get brackets here, but not because I'm creating a list through the operation. Rather, I'm just getting that one element, and it just happens to be a list. So make sure you understand the distinction there between how these 2 operations work. And just to make sure, here are a couple more practice problems. Take a moment, pause the video, see if you can get the correct answers there, and then come back and check your work. Okay, so this first one is a slice that begins at position 2 and goes all the way to the end. That's what it means when we don't have a number after the colon. And so in this case, we're going to get a sublist containing element 2, which is the string PG, and also element 3, which is this sublist. And because we're doing a slice, we're getting a sublist as the overall result here. There's brackets around the whole thing. Now this next one is a little bit tricky, right? We're starting with info -1. So what is that? That is the last element of info. So that's this sublist. And we already saw that over here, right? We did that down here. But then we're saying, give me the last element of that sublist. And so what we end up with is just the number 460.9. Okay, so we're getting the last element of the list that is the last element of the original list. It's a little tricky, but if you just go one step at a time, it's not too bad. Okay, and then we do the same thing for this last one. Info 0 is the string Star Wars, and then we're getting element -4 of that string, and element 4 gives us W. Okay, so given that, go ahead and give this question a try. Pause the video. We want to know how to produce the list containing 105 and 111 from this list here containing 6 numbers that we have assigned to the variable intro CS. So go ahead and give that a try. Come up with the appropriate expression. Now it's possible that more than one expression may work here, in which case you can choose D, or it's possible that none of them work, that neither A, B, nor C work, in which case you could choose E. Okay, so pause the video now and give it a try. Okay, welcome back. So it turns out the only one that works here is the first expression, expression A. So I've added in the index numbers here so you can see why these things work or don't work. So here what we're getting, that first part of it, the slice from 2 to 3, gives me a sublist containing 105. Then the slice from -1 to the end gives me the sublist containing 111. And then when I concatenate those two, I get the desired list. Okay, so that's why A works. Now why does B not work? Well, B is not doing slicing. B is doing indexing. So even though element -4 is the one I want, the 105, if I use indexing to get it, then I'm not going to get a sublist. I'm just going to get the number itself. And the same thing happens over here. When I go to get element 5, I'm going to get the 111, but there's going to be no brackets because I'm not creating a sublist. And so when I go to add them together, I'm actually just adding the numbers, and I get the result 216. And then finally for C, the first part of C is doing indexing, so I get the number. The second part is doing slicing, so I get a sublist. And when I try to put those two things together, they're actually incompatible because they're not both of the same type, and so you actually get an error from C. Okay, now the next topic we asked you to read about for today, and this is going to be a really crucial topic going forward for the rest of the course, is how we define a function in Python. Functions allow us to create reusable chunks of code that perform a function for us, perform some kind of operation or action. And one good analogy is a mathematical function like the square root function or the sine function, things that you've encountered in your math classes. So the one that I'm showing you here is called triple, and it's taking a value x and it's giving me back 3 times that value. Okay, so you can see we have to begin with the keyword def. That's how you begin the definition of the function. You then have the name of the function, which in this case I've chosen to call triple. The name is up to us. We can decide what we want to call it as long as it meets certain criteria, and the book discussed those in the reading. We then have parentheses. Those are required. Inside the parentheses we put what are called the parameters or the inputs of the function. So in this case we just have a single input, and we're using the variable x to represent that input. And then we have the closed parenthesis and a colon. And then just like we saw with if statements, underneath that first line we have a block of code, and it's the block that defines the function, that describes what it's going to do with the input. And like any other block, we have to indent it 4 spaces. And in this case, the block only contains one line, and that line is specifying what the function is going to output. Or the other verb that is used here is returns. The function returns a value, and in this case it's returning 3 times whatever the input is. Okay, so we're going to define this function, and then once we have it defined, we're going to be able to call it and pass in a value for the input. So if I pass in 3 as the input, it will give me back 3 times 3, or 9. If I pass in 10, it's going to give me back 3 times 10, or 30. If I pass in 0.5, it's going to give me back 3 times 0.5, or 1.5. And so you can see whatever value I pass in as the input, I get back 3 times that value. And the way that you make the function call is to have the name of the function, and then in parentheses you put the value that you want to pass in as the input. Okay, now in terms of how we're actually going to work on this in idle, our main approach, at least for now, is going to be to put the functions in an editor window. And I have an example of that here. So you can see up here in the upper right hand corner, I've got an editor window from idle, and I've put my triple function here. And then once you have the function defined in your Python file, this is like what we did in problem set 0 for rock, paper, scissors. So this is going to be a .py file, meaning it contains Python code. Once the function is in there, we're going to run this file. And again, you could use the F5 key for this. That's going to bring us to the shell, but you see it doesn't actually produce any output. So in this case, running the Python file doesn't produce any output. But what we can do after running it is we can go ahead and call the functions that are defined in that file. In particular, we can call triple. So let's say we want to triple 111, and you can see it gives me back 333. Okay, so that's the procedure we're going to use, and we really recommend that you set up your screen the way you see it here. We talked about this in Lab 1. Hopefully you got a chance to read that over last week. Even if your lab was canceled, you got a chance to do it on your own. And we showed you a picture of this layout where you have the editor window in one corner, the shell in another corner, and then over here on the left you can put the problem set or whatever else you're using to help you figure out what you need to code. Okay, so we really recommend you do that. It's a nice way to not have to constantly find the appropriate window. Okay. Now, some more details about functions. One is to notice the color coding that idle uses. So in particular, Python keywords are shown in sort of an orangey color, and strings are shown in green. And one string in particular that you always want to have when you write a function is what's called a doc string. And it's a kind of documentation that tells us, as the reader of the code, what this particular function does. And doc strings are surrounded by triple quotes, and you want to put them on the second line of the function, and they are indented just like the rest of the code inside the function. Okay? But because they are a type of comment, they don't actually get run. They're just there to make your code more readable. And we are going to require that you always have a doc string for every single function that you write in this class. And we will be basing the style portion of your grade on whether you have a doc string. That's going to be one of the things that we look for. Okay, so make sure you do that, and we'll try to make sure we do that in the example code that we give you as well. It is possible to have other comments that are, again, only there for readability. They're not actually executed. If you do other comments that are not docstrings, the way you do that is by starting with a pound symbol, as you see here. And whenever Python sees a pound symbol, it ignores everything from that symbol to the end of that line. And so you can put comments, if you want to describe pieces of your code that might otherwise be hard to understand. Okay, but at the very least, we want a docstring, a triple quoted docstring, on the second line of every function that you write. Okay, now let's look at some other examples of functions here. Here are two functions that take a single string as an input. The function undo takes a string s as input, and what it returns is a new string formed by concatenating the string un to the beginning of whatever string is passed in. And similarly, the redo function takes a string s and it returns the result of concatenating the string re in front of the string s. Okay, so for example, if we were to call undo and pass in the string plugged, it would return the string unplugged. If we passed in the string zipped, undo returns unzipped. So you can do this for any string that you want to pass in. If we pass in submit to the redo function, it's going to return the string resubmit. And then here's one that's a little bit trickier because we're actually combining two functions. So just as you would in math, when you compose functions, you're going to start on the inside and work your way out. Okay, so if I do undo and I pass in zipped, that's going to give me unzipped. I already saw that up here, right? And then I'm taking unzipped and passing it into redo. And so what I'm going to end up with is the string re-unzipped. Okay, so that's a couple of simple functions that take a string and return a string. Now, it's possible for your functions to have more than one line in the block of code that defines the function. So here we have one called circle area. It takes a single number, which is the diameter of the circle. So we're using a variable called diam for that. And then it uses the diameter to compute the radius, and we store that in a variable called radius. And then it squares the radius. So if you haven't already seen this, two multiplication symbols, two asterisks right next to each other, represent exponentiation. So we're raising to the second power, we're squaring, and then we're multiplying that result by an approximation of pi to get the area of the circle. We store that in a variable, and then we return the value of that variable. Okay, so that's a multi-line function, and you can have many more lines than that if you need to. You can also have more than one parameter. So here's a function called rectParim. It takes two numbers, a length L and a width W. And you can see all it does is compute the perimeter of the rectangle using this formula and returns that final value. Okay, so if we pass in 5 and 7, it's going to return 24 because 2 times 5 plus 2 times 4 gives us 24. We can also call our circle area function, passing in 20 for the diameter, and it will return 314.159. All right, now we will sometimes show you code that looks like this. So here in our Python file, we are putting the function definitions, in this case it's the two functions we just talked about, but then at the bottom of the file we're also including a print statement in which we call the function. Okay, and in this case we're only calling one of them. So when I run this, I'm defining both of them, but I'm only going to call one of them at the point at which I run the program. Okay? Now earlier when I was running my Python file with functions in it, we saw that we didn't get any output at all. Okay, and that's because I wasn't actually calling any of the functions in this file. But if I go down to the bottom of this file, you can see I've got that print statement that is on the slide. And right now it's commented out, meaning I've put this pound symbol in front of it so that it won't actually get run. Okay? And that's why, let me just remind you of what happens here when we run this. When we run it, none of the functions actually get called automatically for us. We have to call them ourselves down here in the shell. And that's typically what we're going to do. But sometimes we'll show you code that includes a call to one of the functions or more than one of the functions. So let me comment this out. Let me uncomment this, removing the pound symbol, and save the file in this form. So now, because this is no longer part of a comment, it will make a call to rect_param, passing in these two parameters. And then we're going to print whatever it returns. So let's see what happens when I run it now. So see how we get 56 down here? And that's because that is the result of passing in 20 and 8 for the length and the width. Now, if we were doing this from the shell, we would not need to have a print. Right down here, I could just call the function, passing in the appropriate values, and I'm going to see what it returns right away, because in the shell, when you give it an expression, it gives you the result of that expression. So if you give it a function call, it gives you the result of that function call. But that won't work as part of a program. So if we're going to do that as part of a program and we actually want to see the result, then we have to print what is being returned. Okay? So the function is going to return the value, but we're only going to see it if we then print the result of that function call. Okay. So back to our slides. And here is a clicker question for you to think about. So again, you want to pause the video. Let me just briefly point out what's happening here. This is one of these cases where we have the function, and then right after the function definition, we are calling it. And we are printing the result of the function, the output. So go ahead and try to figure out here what will be the output when this program is run. Pause the video, come back to check your answer. Okay, welcome back. So it turns out the result here is 9. That's what ends up being returned by calculate_3_2, and then we print that return value. So to see why, let's have a table. We highly recommend you get in the habit of doing a table to trace through your code, and we have a separate column for each variable. And so what's going to happen here when we run this code, when we run this program, is first of all, the function gets defined. Now that doesn't actually produce any result at this point, because all we're doing is telling Python what it means when we call the function calculate. So it's going to store that definition in its own memory, and then we're going to skip down here, and here's where we actually call it. And to give you a really clear sense of what's happening here, the picture you want to have in your head is the numbers that we're passing in here are getting assigned to the inputs, to the parameters. And the assignments are happening based on the order in which things appear. So x is the first variable in the list of parameters for calculate, and so it gets assigned the first number, which in this case is 3. And then y is the second variable, it gets assigned the second number, which is 2. So you want to think of it like that, and it's as if we had actually written two assignment statements. X is assigned 3, y is assigned 2. So that happens at the very beginning of the function call. And then we go ahead and we jump to the function and we start executing its code. So the first thing it does is it assigns the current value of y to a. So a is now 2. Then it assigns the result of adding 1 to the current value of x, which gives us 4. It assigns that result to b. And then what we're actually returning is the result of this expression, a plus b plus 3, and that evaluates to 9. And so 9 is what gets returned. Okay? And here again, you want to picture what's happening, which is that number 9 is being sent back to where the call was made, and it is replacing that call. So that call, calculate 3 comma 2, is getting replaced by 9. It's as if we had actually written this in our code. Print 9. Okay? And it's that final value that gets printed, and so we end up seeing the number 9 as the output of the program. And then if there was additional stuff after that print statement, that's where the program would go next. The program picks up where it left off when the function returns. Okay. So let's do a little bit more with functions. Here's another example of a function that takes 2 parameters, a and b. And you can see I'm defining that function, and then in the same program I am calling it, and I'm printing the result of the call. So again, pause the video, figure out what the output here is, and then come back to check your answer. Okay, so it turns out here that the correct output is 5. And here again we're going to use a table to see how things change over time. So remember we said we're first going to define the function, but that doesn't actually do anything yet. It's just telling Python this is what we mean by the function mystery. And then we come down here and we call it. The 2 inputs are passed in, and they are assigned to the appropriate variable. So 0 gets assigned to A, 5 gets assigned to B, and then we jump to the function and we start executing it. And in this case, we have an if statement with a condition that includes an OR. In this case, the condition is true because A does equal 0. And so we're going to do its true block, which in this case is a return statement that wants us to return the current value of B. And now here's a key point. Whenever you hit a return statement, the function is done at that point. We jump back, even though there's more code below the if statement. It doesn't matter. As soon as you hit a return statement, you jump back. And so the 5 gets returned. It replaces the function call. So it's as if we had written print 5, because the function call mystery05 is getting replaced by the return value. And then we end up printing that 5. Okay, so again, the key lesson here on this slide is that a return statement ends the function call regardless of whether there are more lines that come after that return statement. Okay, now just one thing to watch out for here when you're using conditions that include an OR operator. The same thing applies if you're using an AND operator, which is to make sure that you don't do something like what you see here in red. So this would be the wrong way to do it. When you're using one of these logical operators, OR, AND, you want to make sure that the expression on either side of the OR either side of the AND is a Boolean expression. And you read about Boolean expressions for today. You saw that a Boolean expression is any expression that gives you true or false. So that's why we want to write this as A equals 0 or A equals 1. Because on either side of the OR, we end up with a Boolean if we do it that way. But if we do it the wrong way, we have a Boolean on the left-hand side of the OR, but we have an integer on the right-hand side. So you don't want to make that mistake. Now, unfortunately, Python doesn't flag this for us. It doesn't call it to our attention as an error. And the reason for that is things that are not Booleans have Boolean equivalencies. So, for example, the integer 1 is equivalent to true. But that's not typically going to give us what we want. So we really recommend that you avoid doing this, that you make sure that when you use or AND, that you have a Boolean on either side. Okay, so here's another example of calling a function. This is going to reveal a subtle point that we're going to talk more about next time. But I'd like you to try to think about this right now. So again, pause the video and see what you think, and then we'll come back and discuss it briefly. Okay, so it turns out here, and this may be surprising, that the output is 8. All right, and so what's important to realize here is we actually have two different variables called x in this code. And that's because when you assign something to a variable inside a function, which we're doing here in Mystery, we're assigning something to the variable x, that creates a variable that belongs to that function, and it can only be used inside that function. So here we have a variable x, the one that I'm showing in red, that belongs to the function Mystery, and it can only be used inside that function. But then we also have a variable x that we are assigning something to right here outside of any function. So this is not inside a function, it's part of the what's called the global scope. You can think of it as belonging to the program as a whole instead of belonging to an individual function. And so that x, the one I'm showing in blue, is a different variable that belongs to the global scope. And so what happens here is we assign it the value 8. We then make this call Mystery 3, 2, and that ends up modifying the value of x up here, but it doesn't change the value of x down here. And so when we go to print x here, we end up with 8. And so it's really important to understand this. Now, we did not go into detail about this distinction yet, so we're going to be giving you some reading for the next lecture that will talk more about functions, and in particular about this notion of variables that belong to a function, and they're sometimes called local variables, versus variables that belong to the program as a whole that are known as global variables. So we'll be giving you some reading about that. Make sure to check the usual place for the reading assignment for next time and the pre-lecture quiz. Okay, thanks a lot.